In this video, we're going to solve some common economics problems together. So let's just get started. The first question that we are asked is, what is the price in equilibrium and what is the quantity in an equilibrium? The first step to understanding problems like these is that in economics, there are several functions that are in the same graph. So when you look at this blue line and when you look at this green line, these are essentially two functions. You could do as something like this, and sometimes in economics you see further lines. So essentially what they are doing, they are having different functions sitting in the same graph so that you can relate one to one another. Because if you look at this, the quantity being supplied, you have an element that goes inside, and the quantity that is being demanded, you have another element that goes inside. So instead of us having both graphs like on separate charts, we have the same graph in the same chart. So you have the supply here, and you have the quantity being demanded, and both intersect at a point. And this point, the quantity at this point is called quantity in equilibrium. And the same thing goes for price. So the same point has the y-axis related price. So to solve price in equilibrium, the first thing we do is to just equate one expression to another. So it's 1/4 P minus 1 equals to 11 minus 3/4 P. So we just solve the expression, we aggregate the P, so we have 1/4 plus 3/4, then this is equal to 11 plus 1. You just keep developing the expression. This is equal to 1. So this is P equals to 12. So our price in equilibrium is equal to 12. This point here is 12. This is what this means. And to find the quantity in equilibrium, you can use both expressions, either the supply curve or the demand curve. You'll get the same result. So you'll get, let's start with the last one. So it's 11 minus 3/4. And then we know that P is equal to 12. So this is 11 minus 36 divided by 4. So this is 11 minus 9, which is equal to 2. So our quantity in equilibrium is equal to 2. So now we are told for the second question, what is the excise tax? So what's this? Excise tax, or per unit tax, is per unit sold the government wants tax. So they do this by charging a tax. So initially we had the consumer surplus here and the producer surplus here. And now because the government wants in, now we're going to have a situation where both the consumer and producer are going to be affected because the government wants to get in. And they do this by exercising tax. So the consumer surplus, now it's reduced to this smaller triangle here, and the producer surplus is reduced to this smaller triangle here. And in this area, it's what's called the deadweight loss. So essentially, instead of in the beginning, we had like only the consumer and only the producer, now we have a third player. So we are asked to calculate the new price in equilibrium, because what happens is that this curve, the supply curve, is going to shift backwards or upwards. It's the same thing. So it's going to go back to this point where it intersects the demand curve. So what we are asked to find is what's the new price in equilibrium and the new quantity in equilibrium. And if you can see from this, essentially what we have is that there's a new price that is found here, and there's a new quantity that is found here. So this is a higher price, so price goes up, and the quantity obviously goes down. So we need to find the new price in equilibrium that is given by this point. So a new price with a tax in equilibrium. And here the same thing for a new quantity with a tax in equilibrium. So let's find that. In order for us to solve this problem, the first thing to do is understanding that, let me just separate this a bit. The first thing to do is to understand that now we have the price, like the initial price, the quantity that is being supplied, so in our case it's 1/4, minus, and now because we have a tax, we need to reduce the tax, okay, minus 1. And this is equal to the same quantity that is being supplied, so 11 minus 3/4 P. So what does this mean? This means that we started initially here, and now we're going backwards. So to solve this problem, the first thing we need to do is to subtract tax. So we are going from this point to that other point, so we're going this direction, back. So we start with the quantity that is being supplied and subtract tax. So let's do that. So 1/4 P minus tax minus 1. And since we are trying to find the equilibrium point, we are going to say that this is equal to 11 minus 3/4 p. So what we are saying here is that going from this point to this point, subtracting tax, because we're going that way. And now we are asked to find what's the relationship between both of these two. So let's do. So simplifying the expression, we have 1/4 p minus 1/4 t equals to 12 minus 3/4 p. So we can aggregate the same term. So we have p, and then it's 1/4 plus 3/4, same as before. The difference is that we now have 12 plus 1/4 t. So before even moving on, we can answer the question, what is the tax that is being passed on to the consumer? And this is pretty straightforward to see, because the initial price was 12, and now we have 25%, so 1/4, that is being passed on to the consumer. So price plus 25%. So now that we have the price, we can solve for the quantity. So the quantity in equilibrium with the tax is 11 minus 3/4. And then the price, remember that this is the expression that we're using, but this element now, it's this one. So we are going to change this term inside. Let me just change colors. So this is 12 plus 1/4 t. So this is equal to 11 minus, so that's 36 divided by 4 minus 3/16t. So this is the same thing as saying, so it's 44 divided by 4 minus 36 divided by 4 minus 3 divided by 16t. So 44 minus 36, that's 8, divided by 4 is 2. So our result is 2 minus 3/16t. So this is our quantity in equilibrium with a tax. So this is 1, and then let's just write the price here as well. So the price with a tax in equilibrium is the same as saying 12 plus 1/4 t. So these are our new expressions. So now if we are asked to find what's the tax revenue is the same thing as saying a quantity times a price. And the price here specifically is tax. So you are using this expression, so the quantity total in equilibrium, so 2 minus 3 divided by 16t, and that is times tax. So our resulting expression, it's 2t, just distributing both terms across the board. So 2t minus 3/16t squared. So this is the tax revenue. And most often than not, you'll be asked to find what's the value of t that maximizes this revenue. So essentially what they're asking you is for a derivative. Remember that a derivative can either be positive, 0, or negative. So when you are asked to find what's the value that maximizes this revenue, you are here. So where the derivative of this one is equal to 0. This is what they are asking you. So to solve this, so just do the derivative in terms of t, and we'll find that this is 2 minus, so 6 divided by 16t, and this is equal to 0. So this is the same thing as saying, so you can divide both these terms by 2, 3 divided by 8t. So this is the value that maximizes tax revenue. And sometimes they even ask you if this is a maximum or a minimum. Same thing, when you're doing this, you know this is a 0, but we don't know if this is this form or this form, because here the first derivative could also be equal to 0, and here same thing, the first derivative could also be equal to 0. So to do that, we do the second derivative, and we find that from here that it's equal to minus 3/8, and minus 3/8 is less than 0. So this means that this is both shaped downwards, because this is negative. So this is the case. This means that this is a maximum. So this time the quantity that is being supplied, quantity supplied of P, is equal to P minus 1, and the quantity that is being demanded of P is equal to 3 minus P. Again, we are asked to find what's the quantity in equilibrium and what's the price in equilibrium. So let's start. So the first step, as we know, you just equate one expression to the other. So it's p minus 1 equals to 3 minus p. So just change the term. So you have 2p is equal to 4. So price in equilibrium is equal to 2. And we then substitute it back in either this one or this one. It's the same thing. So let's just use, I don't know, just use this one. So the quantity in equilibrium, can do it right directly here, is just 2 minus 1, which is equal to 1. So now we have the price in equilibrium and we have the quantity in equilibrium. And same as before, we're going to be asked what is the new price in equilibrium and the new quantity in equilibrium when an excise tax is being charged. So you do the graph. This is always useful because you have both functions in the same graph and understand what's going on here. So we started off here. So this is the price, this is the quantity. This is the quantity in equilibrium. This is the price in equilibrium. So this is the demand, this is the supply. And now because we have an excise tax or per unit tax, this means that this graph goes this way. So to solve this, to find the price in equilibrium with the tax, what we do is subtract the tax from the initial expression. To solve this, we know that from one expression, because this is going backwards, one expression we remove tax and then we equal to the demand function. So let's do that. So our first expression is p minus tax minus 1. So this is this one. And this expression is equal to the other one. So 3 minus p, right? So what is it that we are saying here? We're saying that the quantity that is being supplied, now we are reducing it by the tax. And because we are trying to find the new price and quantity in equilibrium, we start by first equating to the other one. So this is the second expression. This is the first expression. And all we did was just subtracting the tax because this is going backwards. Okay? So now if we keep going to simplify the expression, we have 2p minus t is equal to 4. So p is equal to 4 divided by 2 plus 1/2 t. So the price with the tax in equilibrium is equal to 2 plus 1/2 t. So this is the first one. And now since we have this one, we can substitute it back into the second one. So our second one, we have 3 minus p, but now we have found p. So what we do in order to find the quantity tax in equilibrium is 3 minus and then the whole expression. So 2 plus 1.5. You're going to have 3 minus 2 minus 1/2 t. So this is the same thing as saying the quantity with the tax in equilibrium is equal to 1 minus 1/2 t. So our new 2 points, this one and this one, are found here. So this means that a 50% tax, 1/2, is being passed on to the consumer. So the price is going up by the tax. What this means is that initially we had the consumer surplus here. We had the producer surplus here, separated by this line. And now because we have the government entering in order to get money as well, so now we are here. So this is the new point, this one and this one. And the consumer surplus, it's reduced to just this box. And the producer surplus, it's reduced to this smaller box. So this middle part here is just tax, this one part. And this second part is what's called deadweight loss, because no one is gaining from it. So the next question is to find what is the tax revenue. And tax revenue is the same thing as saying quantity times price. In the specific case of the government, it's quantity times the tax. So here, because we already have the quantity, it's 1 minus 1/2 t. This is the first one, times t. And if we further simplify the expression, you're going to get t minus 1/2 t squared. And then they are going to ask us what maximizes this tax revenue. And again, we're using derivatives here. So essentially, we can have 3 situations where this is positive, this is 0, and this is negative. So they're asking us what maximizes tax revenue here. So we are asked to answer the following question. T minus 1/2 t squared, the derivative of that, what's the result when it's equal to 0? So when we are here, so the result of it is 1 minus 2 divided by 2 is 1. So we have 1 minus t equals to 0. So this is where t is equal to 1. So the second derivative of this is minus 1, and this is less than 0. So this means that this point where t equals 1 is a maximum, because it's like this. So now we are told that the firm supplies the quantity in equilibrium with a cost function that is equal to CQ equals to 4Q squared. And we are asked to find what's the firm's gross profit. So how do we do this? Well, let's start with the definition first. Gross profit from its simple form is revenue minus costs. And in our specific case, the revenue, it's price times quantity. So we have a price that we found, we have a quantity, and all we are doing is subtracting that expression. So let's do that. So the price times the quantity, as we found, it's 2 plus 1.5 t. Because remember, this is with the tax, this is the real situation. And times the quantity. In our specific case, we found that it's 1 minus 1.5 t. And that minus the costs, so 4q squared. This is our gross profit equation. So to solve this, we're going to get 2 plus t plus 1.5 t minus 1/4 t squared minus 4. And this q is the quantity, so it's just squared, but this is the same expression. So 1 minus 1/2 t again, this is the expression that we're working with, squared. And the resulting expression, you can do this on your own, but just to simplify this a bit in terms of time, so the gross profit is equal to minus 5 divided by 4 t squared plus 7 divided by 2 t minus 2. So this is our gross profit equation. So now we are asked, where is it that the profit is maximized? The same thing, we can either have a situation like this or have a situation like this. In both cases, we are asked to find this point, whether the first derivative is equal to 0. So all we're doing here is finding the first derivative of the gross profit equation. So minus 5 divided by 4 t squared, then 7 divided by 2t minus 2. So we are asked to find the derivative of this is equal to 0. Sometimes you'll be asked to draw the full function, and we can do that by using the elements that we have here. So to do that, let's do some values here. So we know that gross profit in terms of t, and we know that 7 divided by 5 is here. So we have a corresponding value here somewhere. So to do that, to find this value, all we need to do is plug in 7 divided by 5 in each t, and you'll find that the value is 9 divided by 20. In order to find where the graph, the points where the graph hits 0, so we need to use a quadratic equation with this one, so you can find the values where the expression is equal to 0. And you'll find that these values are 2 and 4 divided by 5. So this means that our expression is something like this. So like this, and then hits this point. And we also be interested in knowing what this point is. So the point where this graph intersects y equals 0. So all we are doing here right now is not finding where these values are 0, but where this is equal to 0. So we're essentially equating all this expression where this is equal to 0. And you'll find that this point is equal to minus 2.